I would like to start with asking maybe who is already interested in using, let's say, different types of LLMs for maybe daily tasks or something else. Feel free to share in the chat or by unmuting yourself if you want. I will actually share a couple of recent experiments that we are doing and also giving a small demonstration from two different, let's say, style of tools. One of them would be like kind of empowering the some kind of available packages with the AI, and the other one is basically just let's say using specific LLMs for the whole data analysis workflow in general. So this is going to be just small demonstrations, but I will go through with some, let's say, examples in the literature, how it is changing recently, and also try to share our recent findings. When I say recent findings, you will see mainly a couple of summaries, and also we are about to summarize the information that we collected. So I will also show a couple of answers that might be interesting for that, let's say, part of the literature directly from the GitHub repository that we are working on with my, let's say, colleague and also one of the PhD students that we have here. So let me just share the screen, first of all. Hopefully it is visible. The main title is going to be LLMs for Statistics and Data Science. I will explain why. And I'm hoping to share some reflections on the recent experiments by giving, let's say, some examples from literature also, and also small demonstration. Our starting journey is this, let's say, the preprint paper. At that moment, we are working on doing some revision and resubmitting again with the recent findings as well. And we realize that, we are not alone in this planet for sure when you start thinking about to do some analysis or research, and we realize there are some related studies. So we try to make our one a little bit separate in terms of how we are, let's say, treating the responses and how we are doing the experiment compared to the other examples in the literature. First of all, I'm going to start with some background information, especially if my slides work. Oh. Come on. My screen looks like a bit frozen. I don't know why. Yeah. I'm just skipping that part, but if you know me from the DRP program, working as a lecturer in statistics in the School of Math, and I have been interested in the recent, let's say, LLM improvements and the advancements in the field, especially how it is, let's say, reshaping the teaching and learning, and specifically how it is actually affecting the code-based courses from our perspective. I guess this was one of the motivations why we are doing this experiment also. And primarily, there were some studies so far, like the programming with LLMs. There are recently written books about how, specifically named as ChatGPT, but let's say the one LLM tool can be used for programming, and how it is used for learning programming. Some people are investigated in this direction. For instance, AI-assisted Python programming is a very recent and solid book written by some colleagues in US. And on the other side, not only learning programming, we can also talk about how data analysis can be empowered by the recent LLMs. This is not a new topic because if we just narrow our focus to the AI assisted coding, or let's say AI assisted data analysis, there are some preliminary works earlier on, but nowadays Gen AI is also affecting heavily. And we can think about two main streams under this title. Using these type of tools as a helper, especially for code writing. This can be one aspect, but also we can use these type of tools to do the data analysis from scratch directly. And especially the paid membership of, let's say, OpenAI's ChatGPT with additional tools is really promising in that part of the field. This is not only, doing the data analysis, but also getting some kind of maybe the final reports if you specify in your prompts immediately. And we will see that there are some interesting examples in the R side and also the ChatGPT side through the demonstrations. Some pilot studies are actually incorporating these type of tools for teaching and learning so far, especially for data science course. It feels and seems like inevitable, but in the meantime, we need to be careful about how it is actually used and how should we inject it to the, let's say, teaching delivery. Otherwise, there could be some dangerous impact on, let's say, the learning process as well. These are some pioneering works, let's say, using the Copilot for data science. And also, you can find more about these. In addition to the, let's say, GitHub Copilot, there are so many interesting tools out there. These are specifically designed AI assistants, including, let's say, Tab9 or the Code Whisperer and so on, that allows you to write code, let's say, easily. But when we say easily, it does not mean that maybe you are really learning something. So just to make a warning about this. More recently, there's a concept called vibe coding, which is thrown by some pioneering, let's say, or the leading names in the field as well. I guess many of you possibly agree on this comment in terms of the recent, let's say, technological advancements. Everyone deserves the ability to automate tedious tasks in their lives with computers. I guess this is again appeared more visible after the, let's say, appearance of so many LLM tools in the generative AI side. And even some people like Andrea Karpathy and also similar names in that field saying the software engineering side or the software writing is also under a big change. So even if you forget to add something in terms of your code writing, or even if you actually haven't write any specific syntax, by just communicating with these tools in English, you can get very promising code results or very promising code suggestions. There is an ongoing debate on that in terms of vibe coding, and some people are saying that if you are actually, writing your code with the LLM, but if you are actually making sure that you are testing it and you're understanding it and reproducing some of the results, this is not the vibe coding. This is actually a kind of a software development with the help of LLM. But I guess, the boundaries are very gray in that sense. So it depends on how people are using. And very interesting quote from these two people is about just because a machine can write like us, it does not mean it can think like us. So the reasoning discussions is also a very hot spot nowadays. And some people from Apple, for instance, researchers from Apple declare that in terms of their recent paper, this is not the reasoning that we understand from the human being perspective, actually. This is about, capturing the patterns and understanding the patterns to create what is the next possible, let's say, token or word, even if it is code base. This is doing the similar thing. And LLM actually doesn't care about the, let's say, truthfulness or correctness from that perspective as well. That's why we need to be careful about while using these tools. When we look at the data science and statistics more specifically, some people are started to use these type of terms like ChatGPT integrated data analysis. The reason is obvious because OpenAI's ChatGPT additional tool, which is called previously, let's say, code interpreter or advanced data analysis, really allow us to do some analysis, just simply asking very simple prompt. If you, let's say, upload something, I'm going to show in a couple of minutes, and if you ask very generic prompts, still you can get very promising, let's say, draft of outcomes, I would say. And it may really create your specific data analysis reports eventually. And from the teaching perspective, I guess we are really concerned about this, even in here and most of the schools as well. This discussion is also related to automation concept in the data science and related tasks. It is not a novel debate, but the LLM impact is, again, very, very visible and huge nowadays. And we can see that some people started to do some let's say, experiments or analysis, how those LLMs are good enough on, let's say, data science tasks, or how these are good enough on the statistics. In our recent work as well, we were experimenting from that point of view. But before diving into some of the results coming from the recent project, I'm going to show you very interesting summaries on how these type of LLMs are reachable within any specific programming language. It's a very long list for our language here. It's very fast moving, so that so many providers or developers are creating specifically designed or nuanced, let's say, packages that allow you to communicate with LLM for a specific purpose. This is not about, interacting with LLM within its interface. This is about really importing some R package so that you can communicate with the LLM within the R environment or R interface. Uh, I haven't tested many of those yet, but there are some very interesting examples, like which model behind the scene is running can affect the name, like Gemini R, or let's say the ChatGPT oriented one, I guess. Elmer is one of the official one coming from the Posit group, Posit company directly. They were investigating on that, investing on that direction, so that different LLMs behind the scene can be picked up, and you can communicate these tools within our interface, whatever the integrated development environment that you are using generally. This is not only for R, for sure. As I said earlier, there are some interesting examples, including GitHub Copilot. And nowadays, there are some extensions called Continue or Codium that allows to add VS Code extension so that you can get some help from those LLMs to write your code. They are very interested in nicely fitted integrations of those tools. And especially when you look at the R side, there's one interesting example is coming from the Shiny package. I'm going to try to show this one where it is exactly. This is, for instance, custom GPT, which is designed by some developer. Let's say R and R Studio Tutor is a customized GPT that you can reach out within the GPT market, as an example, especially after 2024. People started to produce so many different GPTs, which are designed for certain tasks. This is just one example, I would say. And special mention can be actually set for Shiny Assistant. This is very interesting as well. If you haven't heard about it, Shiny is a specific package. Previously, it was written only for R, but nowadays you can also use for Python as well, so that you can create some web applications with the Shiny syntax. Primarily, you have the user interface component and also the server component within your code, so that you can describe everything in a one single R file or one single Python file. When you actually run that application, you can immediately get some very fancy, let's say, web application results regarding maybe some data analysis or something else. I'm going to show this one very quickly, if that slide allows me to move on, just to show you, how these are really powerful nowadays, actually. This is, come on. Hopefully it will turn out and show something. Let me just restart. Sharing, just in case. I'm just switching to Shiny Assistant that I said in the slide. Previously, you were actually, in some sense, alone, without any help from LLM directly. And you need to figure it out, what are the use cases, what are the examples in the gallery to mimic what other people wrote in terms of the code, and try to produce your own web application with the Shiny running, let's say, behind the scene. This is actually available since October 2024, if I'm not wrong. If you just, let's say, try to write down certain prompt, This is again operating by, let's say, Shiny app behind the scenes so that I can immediately see what is the user interface when we click it. You can switch either R or Python in terms of your needs. And you can play around showing code only or concise, which means all the, let's say, details, including the code aspect. Verbose, I haven't tried, but most likely in terms of the narrative, we can just see what is the general outcome in terms of the text. But let's say in terms of the concise, similar to the user interface of those LLMs, you can enter your prompt here and to get some really promising draft or outcome immediately. I know that there's a data set called diamonds in the ggplot package, for instance. I'm going to show you a very small example from there. Let's say create a very brief Shiny app to summarize the diamonds data in terms of, let's say, 3 main visualizations. This is very generic. I haven't specified which type of visualizations or which type of, let's say, variables that I'm interested in. But I know that this is coming from ggplot. So when you send your prompt, it starts running similar to the other LLM interfaces and saying that, okay, I'll create a Shiny app, 3 main visualizations to summarize this data and start writing something. And you will see that the single R file is started to be created here. And in the meantime, we can see what is the components of this R file. I mean, if you haven't, heard about it, or if you haven't done anything, it might be a little bit awkward, but no worries about the details, what is written in the R file. My point is, with a single prompt for a very specific package and for a very specific task, we have very powerful assistant like this. And it is originally importing and uploading all the necessary, let's say, libraries and stuff and creating the corresponding R file. If everything goes well, hopefully. Oh, interesting. This was not the case when I tried earlier on, but possibly creating this error, and we can say, okay, fix that error for me. This can be a follow-up prompt, or let's say simply create one histogram from diamonds data. Let me simplify for an illustration. I guess it should be some price variable. It is immediately, changing the components and creating the necessary parts like the user interface and also the server behind the scene, and creating this histogram. So you can imagine all of those data visualizations and some narrative all together create a web application actually. Now we have a very interesting and powerful tool to start from, not from scratch, I would say, by simply asking certain prompts. This AI-empowered actually assistant can help you and can guide you through the process. And even these, R files can be very good drafts for your original task or original goal at the end of the day. What I tried earlier on, for instance, just starting from a JSON file and give me a template for it. And if it is working only for 3 observations, possibly I can use for the larger JSON file that I'm dealing with, for instance. This is a very specific example to, let's say, empower what is already available in R field or R world, specifically for a Shiny package. But if I go back to my slides, hopefully I can move forward. After a couple of slides, I will also show you another demonstration on the ChatGPT's code interpreter aspect. This is also the backbone of our experimentation as well. But let me give you some little efforts that I have done so far before that project. Especially creating a labeled data for these type of experiments is very crucial, like the question and answer pairs. These are the starting points so that you can do these examination and testing in a systematic way. I had a chance to work on some data science course related quiz questions earlier on. This was my initial effort on this, let's say, area in some sense, and try to give specific labels for certain question types in the multiple choice question style. Whether it is a true false question, whether it is yes no, or whether it's a fill in the blanks and these type of things. I was interested in how those, let's say, earlier versions of the LLM are performing well or not. This is just the illustration on the ChatGPT response, the ChatGPT 4 response over different set of questions, which represents different quiz questions, quiz exercises. In total, we have 10 questions for each. And for each of the cell, we have different type of questions. So we can see, in which aspect it is performing well and which aspect they are not performing well. But all of those experiments that I did earlier on, just relying on the earlier versions of those tools, like Google's BART, for instance, before the Gemini. This was just an initial effort, and then we proceeded further with the specific data science tasks rather than multiple choice questions, because in the data science or the statistics field, we have very interesting close-ended or open-ended style questions, including some, let's say, data processing or data usage. This might be also necessary. And earlier on, we started with a examination of the data analysis capabilities of the ChatGPT again by asking very simple prompts. Let's say, this is my data and give me a data analysis report, or this is my data, do some data visualization. It is like zero-shot learning style questioning. And the only thing that we are doing is, uploading the data and asking very simple and unclear prompt, or let's say unspecified in terms of the details, but asking these type of simple prompts resulting in very promising drafts still. And we try to explore actually different types of tasks, like examples from supervised learning or unsupervised learning, to cover a rich set of data, a rich set of, let's say, exemplifications. And we just actually rely on two main data sets that you can see in the middle of the slide. One data set is coming from Kaggle, and the other data set is coming from R package. But in terms of the process, we had the CSV versions of those files, and we were uploading to the interface and asking our question. This was the, let's say, initial examination. And what we have done earlier on, in terms of the generated response, let's say, how the data analysis extension within the ChatGPT, let's say, performing well or not. And we actually created a kind of 5-star system, actually benefiting from the literature, without specifying any details or any detailed metrics to measure how the, let's say, response is well enough. It was just intuitively giving a certain number of stars out of 5 by looking at the output. Let's say if it is in a histogram, if it is satisfying certain conditions, and if it is matching with the, let's say, the data set itself, it is, let's say, roughly 5 out of 5. But if there were some problems, we were giving, let's say, less stars on that. This was the initial experimentation that we have done. And then during those times, we started to think about, how we can do this in a more systematic way, and especially how the results are actually changing whenever we are asking the same type of question over and over again. This is the initial motivation for the recent project that we are running. In terms of the initial observations, what we can say basically, especially in the data visualization scenario, you can see very messy outputs like this. The question was creating a mosaic plot for the categorical type of variables, for instance, relying on the data. Whatever it can see as a categorical variable, it tries to put everything together because of the prompt structure, and also because of, let's say, directly creating in terms of the prompt that we ask, so that we are ending up with this messy image, not readable at all, and actually not interpretable in the meantime. And we were investigating these type of interesting aspects in our initial experimentations, and even asking a couple of times, you can end up with different selection of the categories, for instance, or you can end up with different choice of, let's say, geometries in the data visualization. Like, even if you are saying the dot plot, for instance, you can see some results in terms of the line plot, as an example. Because of the inherited randomness of those tools, unless you are very clear on your prompt, very specifically writing all the details, there is no guarantee. But even if you are creating a very specific prompt as well, or the clear prompt as well, still you can end up with very changing results in terms of the generated responses. This was the initial observation belonging to our draft paper. And then in the recent project that we are running all together as a group of 3 here, with a colleague from School of Mathematics in here and also the PhD student, we started to do this experiment in a repeatedly setting, in a repeatedly manner. By borrowing the idea of the, let's say, the concept of the Monte Carlo, let's say, simulation setting in the field of statistics, we can say, okay, how about asking the same question, let's say 100 times, or let's say 1000 times, how the responses are changing and how we can actually measure the quality of the outcome and how we can evaluate the created response. These are the main challenges that we are facing with. Once again, we focus on the GPT tool coming from OpenAI, and also integrated with the code interpreter or the data analysis, whatever you call, so that behind the scene, whenever it is necessary, the tool itself can trigger the Python coding, for instance. Thanks for letting me know, Gus. No worries. In this process, by the way, we started to create a data set, list of data set, first of all, to, let's say, mimic some of the benchmark style ideas in the literature. Many of the question and answer pairs are coming from, let's say, different courses, different topics, and different difficulty levels. And we were interested in actually creating a list of evaluation metrics as well, rather than giving an intuitive 5 stars, for instance. These are our, let's say, initial motivation on that. Even if we tried a couple of times, as I said earlier, there are some, let's say, misleading outcomes, like the measure of the units can be changed, not consistently applied for a very specific variable, for instance, a price coming from a certain data. And even if you are creating let's say, a data visualization, the narrative related to data visualization might not matching with the interpreted numbers or the presented numbers in the plot itself. This happened a couple of times on the correlation heat map. And for the histogram example, for instance, when we tried on the laptop data set again, in our initial repeated experiments, I would say, sometimes randomly it is adding the density curve or sometimes not. So it is really, following certain internal, let's say, ideas that we haven't actually set by the given prompt. The original question is asking just the histogram itself, for instance. And this might happen on, especially on the data visualization side, but even in the, let's say, modeling type of questions or the data summary type of questions, you can see variations in the outcome as well. Or also you can see the reasoning or how the responses generated can be changed from time to time or iteration to iteration. Just to show you some of the relevant works, I can focus on this table, I would say. What we were trying to do is deviating from this available work so far, so that prompt sources are directly coming from human written questions coming through different courses, not focusing on just the code base related questions, but primarily focusing on different data science tasks or the statistics tasks that we are asking to students, for instance. And we have also some, let's say, solution key for many of them so that we can compare with the ground truth as well. This is also possible. And in terms of the evaluation metrics, if you look at this table, they primarily looked at the pass rate or the, let's say, LLM human collaboration to understand how the quality of the response is actually measured. From time to time, you can see accuracy rate or the test cases in terms of the coding part as well. There are some testing on top of the created code. What we have done so far, by reflecting on the available literature and also the necessity of the, let's say, task-specific details, we try to create our own evaluation metric list under 3 main subfields. I'm going to give that list, but before doing this, let's try to see, how it looks like when we try to get some outcomes from the ChatGPT interface. In the project itself, we had to do it with the API communication, API key usage communication. The reason is that we need to do it repeatedly. So rather than using the original interface, we were communicating with the selected LLM. So asking the same prompt over and over again and collecting the results in a systematic way. This was the main reason for that. But if we, let's say, try to do the similar thing in terms of the ChatGPT interface, it will look like this if you haven't done anything. Let me try to show you how it looks like from the interface itself. Originally, this is just a GPT-4o model without any code interpreter is initiated. Previously, it was possible to initiate from this list, as far as I remember. But now the external tools are a little bit limited to searching the web or writing the code. But the writing the code part is just mainly writing the code. So sending a query, for instance, like give me the function for calculating mean of a data set, for instance. It is on the canvas creating a function look like this, and mainly speaking, creating the function actually in terms of the Python syntax. This is heavily depending on the Python libraries and let's say programming language usage. So giving this sort of result, let's say, this is the function. Most likely, if I upload some file and ask a question, it can initiate the, again, code interpreter behind the scene and give us some result. But I'm going to show you in a different way, especially for the GPTs. As I said at the beginning of the slides, there are so many interesting custom GPTs, right? You can also do your own custom GPT as well if you are a paid membership, let's say, holder, so that you can create your own GPT here. For instance, Tutor or the R Studio, if it is searching or it is available, it should pop up here. Yeah, this one, for instance, that I highlighted in my slide, R Studio Tutor. So this is a custom GPT so that it can create R codes, whatever you're asking. So we have a similar idea for creating the data analysis called interpreter-based GPT. This is the one that I created, data analysis called interpreter. I can immediately see here, but you can find so many different alternatives, most likely. How it looks like is basically, if I open from here, in terms of its general settings, you can see from the edit, the code interpreter and data analysis capability is open. So in terms of the prompt that we are sending to the LLM, whenever it is necessary, it should identify and trigger the code interpreter tool, let's say, automatically in some sense. So if I, let's say, upload the data, similar to what we are experimenting in our original setting. Let's say a CSV or Excel file. I guess I have already something to ask from here. Yeah, the cherry blossom data. Let's say, give me the histogram of 10 miles. I know some details from data. That's why I'm asking in this way. But you can just generically say, give me some data visualization, right? So it is parsing the file and reading the file, first of all, and initiating the Python environment with the help of code interpreter, let's say, and start doing some analysis, even if we are asking a very generic prompt, saying that, okay, data set contains these type of information. And then I can create those. When you click this part, view analysis, you can immediately see what is the code behind this. It is about just reading and looking at the first few rows. But we will have similar, let's say, convention for the created images like this. Age distribution of runners and the pace distribution of gender, trying to separate with respect to male and female, for instance. And just focusing on these two, creating one histogram and one multiple density curve, and also the bar chart immediately. But of course, the idea that we are sticking to for the project itself, how about when we ask the same thing once again? You can see immediate changes on the result when you actually rerun this part by editing the message and sending again on the same set of data. But to make it more generalizable, we were investigating our questions across different type of data sets. Either it's a CSV file or Excel file or, let's say, text file. There are some other possibilities, but mainly speaking, it is easy to work on these type of data set files in terms of general experiences. So that we focus on this. And immediately you can get some reasonable suggestions on that. And if you click again this type of view analysis, we can see reproducible Python code behind the scene. Whenever you open this part, always show details. You can see both code and the image side by side. And it is really, ready to copy and paste in a different environment so that you can get the similar results, or you can actually adapt these suggestions in terms of your need. These are all, let's say, possible help that we can get from ChatGPT plus code interpreter, I would say. If I do the same thing from here, let's say, edit message and send it again. In the new session, actually, it is creating a new message thread and analyzing the same data and trying to create possibly similar or different data visualizations once again. For this very not specific prompt, I would say, starting with the same summary of the data set variables, age distribution. Yeah, looks like, yeah, now asking before generating anything. Let's say create all of your suggestions as a follow-up. We will see that the created images after the second round of, let's say, analyzing, it says, it's just triggering the code interpreter in terms of the dataset details and trying to write down the relevant, Python codes to generate images. And then in terms of the model, or let's say in terms of the prompt, let's say complexity and these type of things, of course, the running time is also changing. We got almost the same thing here, but now pace distribution is created in a different style, as you can see, rather than density curve. Now we have the histogram. I guess the rest is almost the same, if I'm not wrong. But we have one more additional bar plot, if I see it correctly. Yeah. And you can also see the previous version from here by going back to the previous outcome. I guess, yeah, we have one more additional bar chart, for instance. So the number of images are changed, and also one of the structures also changed. These were, main motivations for us to see how we can see and how we can evaluate. So far in our experimentation, we tried different types of questions and focusing on different tasks primarily. Let me go back to slide for a while. As I said, all of them coming from human written prompts in some sense over different set of data and coming from different courses. There are some also open source additional data sets that we can consider, but we haven't touched yet. We created our question formats look like this with a specific ID, the question itself, the concept and the level can be changed in terms of the type of the task. The concept can be changing, like either it is data understanding or data visualization or statistical modeling. And the level is related to difficulty level. So we have mainly three options like easy, medium, and hard. So we created our labeled data before starting our experimentation. And this is a kind of a summary of the tasks that we were interested in. And there are some count data on the easy, medium, and hard type of questions. All of them are actually, labeled by the research team so that manually labeled and without asking any LLM and so on. In terms of the, let's say, the complexity of the question and in terms of the different nuances of the questions, we separated into easy, medium, and hard. And how the task is created is giving the indicator of which type of task that we are asking generally. So far, in terms of experimental trials that we collected, we had the model GPT-4o and also a code interpreter attached to it. And we are also interested in investigating these alternatives, like what about the impact of the model change, or what about the model, one of the main model parameters change, for instance, the temperature value. This is still under investigation, but I can say some initial observations from those. For instance, if I just simply change my temperature from 1 to 1.5, 1 is the default number. 1.5 looks like very large for it. Even very well-known, very simple tasks, the created response is started to be broken, and you can see so many weird characters and so many unreadable text as an example. All of those are under investigation, but since the code interpreter is heavily depending on Python language, whenever you are trying to impose some additional constraint about the language programming language, like give the result in terms of R packages or let's say R libraries, it is not working as properly as the Python. Our initial investigations showed us in a very, again, a simple question about the data understanding. The created code, for instance, not directly coming from R as an example. The code interpreter is trying to initiate the conversion from, let's say, somehow from R to Python or Python to R to write down the necessary code. But from time to time, it is directly failing at the task and without giving any reasonable outcome, as an example. I guess the metrics are very crucial and critical part of this work, and we are about to finish this list. Specifically, we can look at the general properties of the created response. Since those LLMs are working in terms of the units called, tokens or the words, we can have a look at the number of tokens or number of words in terms of the created response. And by comparing with the input, we can also get the verbosity ratio, like the input over output, for instance. It is possible to see what about the runtime, how it is changing across each iteration. When I say each iteration, you can imagine, let's say, 100 different times we are asking the same prompt and collecting these type of properties. In a similar manner, by the way, this is one subfield of the metrics, like the general properties of the outcomes. And the second one is called coarse-grained. So we are interested in here, under this title, what is the completion rate? Or what about the accuracy of response or executability of code? And how about the generated text similarity when we compare with the either ground truth whenever it is available, or either comparing with the, let's say, first round of outcome that we collected, which can be also a reference point for us. It is possible to create these type of summaries on top of these, such as this is one of the specific data that we are experimenting. And this is the, let's say, change across different questions under the same data of the number of tokens of the output. And this is the verbosity ratio. And this is the similarity index calculated in terms of the idea of Jacquard similarity as an example. So we can see these type of nuances when we look at different, let's say, sort of questions that we have. Such as ID 0 belongs to such a simple question, which is labeled as easy. The other one is also labeled as easy because of the same type of task, which can be called as data understanding. But the input number of input words or the number of input tokens a little bit higher than the other one. This is somehow resembled in the output tokens here. If I just focus on the ID 0 and ID 4 as an example. These type of numerical nuances can be visible. And we can also look at the completion ratio, look like this. Most of the time, it is actually calculating the correct output. Just one single case couldn't correct the or couldn't get the correct answer when we compare with the ground truth. It is actually somehow failing, even if the execution of the code seems completed. Actually, it doesn't create any reasonable output, for instance. We are also collecting the summaries on these type of, let's say, details like the completion ratio and also checking the code executability. But actually, if you look at the data visualization type of outcomes, it is much more, let's say, joyful. There are very interesting selections, like even if you are asking, create me as a dot plot, there are some bar plots over here, a kind of a combination of line plot and dot plot. And also the background color is changing randomly. And also even here, there is no dot plot at all. So the legend location and how the colors is selected and how the original geometries like the dot plot or line plot or the bar plot that can be changed as well. So we were trying to evaluate these type of outcomes in terms of certain metrics that we created. Speaking of the metrics, we are listed those under data summary so far, data visualization, and also the statistical modeling. Specifically, we have different types of actually nuances in terms of which type of modeling we are applying, because the specific needs of the linear regression in terms of the evaluation is changing compared to the tree-based model, for instance, or if it is an unsupervised learning method like the PCA or the clustering, again, the list of metrics can be changed or subject to change. So we were actually listing the grants, not the grant root. We were listing the common grants for each of the tasks and trying to make it our, let's say, 5-star system more solid and more reasonable or numerically measurable, I would say. So all of them are a kind of a list of metric or the list of rubric items in some sense, so that we are going to give some mark for each of the aspect over 100 trials, so that we can end up with numerical evaluation for each. For instance, if I go back to data visualization example for this first illustration, one of the items here the data viz completeness. So whether the requested visualization is generated or not. If I just focus on the generation of the image, it looks like it generates something. But if I also look at some, let's say, details or the, let's say, common ground aspects of the successful data visualization outcome, the aesthetic mapping looks reasonable in terms of, let's say, how it is treating different, let's say, faculty members, and also how it is creating the y-axis as well in terms of the employment percentage. But actually, the selection of the geometric object, whether it is matching with the asked question or not, we have a failure here. We asked dot plot. I would like to observe only dots here in terms of my prompt, even without any line. But in the first example, it creates a bar plot without no reason. So in terms of the geom layer, geometric object, it's a kind of misuse or mismatching in terms of the prompt versus output. So from that item, for instance, it is taking it is taking 0. So in terms of these details, nowadays we are giving those numerical measures for each of those in terms of the selected questions out of our whole list. Not marking all of them, but focusing on certain tasks, I would say. This is what we have so far. And finally, we are going to explore different model settings and also how it is affecting the outcome. And in the meantime, how these type of evaluation metrics are, let's say, possibly applicable across different tasks. Because in which way I'm asking the question somehow affecting actually these type of metrics from our perspective. But we are focusing on the common grounds for each type of task. For instance, in the linear regression, I would like to see the recognize, let's say, significance, for instance, and this type of nuances. These are constituting our list of metrics for us. I guess I'm going to skip that part a little bit. Maybe in the discussion, you may ask what about the teaching perspective or teaching and learning perspective if you're interested in. But the whole story so far, how these tools are really powerful and rapidly evolving and actually injecting everywhere in some sense. In the last week, even, for instance, Google announced that you can call some AI helper in the cell of an Excel file to do some task, as an example. So looks like these are actually injecting to our daily lives more and more. And by quoting from the Andrei Karpathy, he was also saying that this is a kind of an operating system. There's an analogy to say LLMs are not only the tools, but becoming an operating system. That means that even in the local, in an isolated way, we are going to use these type of tools, looks like. So it is also affecting how we are doing the data analysis. And it is also affecting actually how we need to teach data analysis from that perspective as well. So in the discussion part, I'm happy to see your comments, questions, and whatever you have. Yeah, let me stop here because of the timing.